Today, I'd like to introduce you to a piece of technology that revolutionized aviation. It contributed to a reduction in accidents and fatalities. It's easy to build, easy to use, yet surprisingly has only been around since the mid-1930s. I'm talking about checklists. Hello and welcome to our Tech Talk about building checklists for production machine learning. I'm Seth Clark, co-founder and head of product here at Modzy. Before we dive in, this Tech Talk has a corresponding blog post on Modzy's website, and the checklist itself is available on our GitHub. You'll find links to both in the video description. If you're in the business of building, running, or using ML models, consider subscribing to our YouTube channel where we post regular videos about working with ML in the wild. Now let's get back to the humble checklist. So where did it come from? In 1935, the Boeing Model 299 was undergoing a flight test when one of the flight controls, something called a gust lock, was accidentally left engaged, resulting in the plane's crash and the deaths of 2 pilots. Instead of canceling the program, however, the U.S. Army Air Corps responded by creating the first known checklist, meant to help new pilots avoid similarly costly errors. This plane was eventually adopted into service as the B-17 bomber, which you may have heard of, as it was in heavy use during World War II. It's worth noting that aviation checklist was particularly important during takeoff, approach, and landing. Although those segments comprise only about 27% of average flight duration, they account for over 76% of accidents. So the idea today is to apply this philosophy. Think about the opportunities we have in machine learning to minimize risk through the creation of a production ML checklist from first principles. We want to minimize risk inherent to deploying new models into production with the least amount of effort and steps possible. You can use this approach to build your own custom checklist, or you could start with the one that we've put up on GitHub. So first things first, what makes for a good checklist? Well, according to author, surgeon, and checklist enthusiast, Dr. Atul Gawande, who literally wrote the book on checklists, a good checklist should be precise, to the point, and easy to use. It shouldn't try and spell everything out. Instead, you should focus on adding in reminders of the most critical and important steps that might otherwise get missed. More than anything, it should be practical. So with that in mind, let's build a simple checklist that maximizes risk reduction. We're about to min-max AI. Now I'm going to start by proclaiming there are 5 things that we should all want out of a production model. 1 is that it's returning predictions. 2, that it can talk to other software through APIs or SDKs. 3, that it's fast and responsive, but only as fast and responsive as the business rules dictate. 4, that it's about as accurate as you expect. It doesn't have to be amazing, but it needs to be performing in the way that you expect. And finally, 5, nobody's hacked it. If all 5 of those conditions are true, you're going to be in pretty great shape. So let's devise some error traps that we can turn into checklist items to help make our dream a reality. If you've done this before, ask your team to create a list of all the issues that they've run into in the past. If you haven't done this before, here are some common issues that might pop up when you're in the process of deploying your models into production. Issue number 1, deploying the wrong model version to prod. If you're managing even a few models, it's incredibly easy to accidentally deploy the wrong version. You may have issues with models behaving strangely because you accidentally deployed an old version, or perhaps other software that you're using that's connecting to that model is pointing to a wrong version number. Issue number 2, you're missing key model info. When devs are trying to connect to your model, it's easy to miss important info such as what the data format's supposed to look like, what kinds of response times should we expect. When that happens, who do you call to get that information from? If there's no one listed against that model, it becomes really hard to debug. Issue 3, unexpected model performance. Sometimes models, they just don't work right in production. Was the model tested on the same kind of hardware that you're using in production? Or was the same data volume or type of data used in the testing process? Is it experiencing the same amount of traffic that it was tested on? Issue 4, stuff is breaking and I don't know why. Sometimes stuff just breaks. Technology is imperfect. But are you able to figure out why your model isn't working? Is it slow? Is it wrong? Is it offline? Did the input data change? You're going to want to be able to get answers quickly so that you can fix the glitch.
So we just went ahead and fixed the glitch.
So we'll try to build some error traps for these common issues and a few others into our checklist. Drumroll please. Here's what the checklist might look like. Here you can see we've built error traps to document the most important info about the model, Double check the model name and version at each step in the process. Test the model on the same hardware, data, and workload as will be experienced in production. Ensure no one can touch the model without permission. And make sure we always have enough info to quickly debug model issues and roll back changes if needed. Now, how you choose to put these checklist items in place is a whole different story. One more aviation example for you. The Convair B-36 Peacemaker had a pre-flight checklist that took over 6 hours to complete. Not only did this cumbersome process hamper the Air Force's ability to deploy the aircraft quickly, but you can imagine that during the 6-hour slog, most pilots have turned their brains off. As a result, flight risk remained high because it was easy to check off items that hadn't been successfully completed or had been completed haphazardly. The lesson here is to look for opportunities to automate parts of the process that don't benefit from human intervention. MLOps tools provide a way to automate low-risk items so they no longer need to be a part of your checklist. Things like checking on the model name, ID, version number, those can happen automatically if you're using a model serving platform like Modzy. Similarly, you might choose to automate a set of tests that simulate a production workload in your test environment, finding the same combination of GPU, CPU, and RAM settings that you know you're going to have in your production system. You might also set up a CI/CD pipeline that automatically documents a model's author, training data, validation metrics, all within GitHub or some other centrally available resource. The point is to focus on designing a checklist that takes advantage of these tools to automate tasks that don't benefit from human oversight. So there you have it. If you use these principles to build a production checklist, you can reduce error, improve uptime, and still give engineers the freedom and flexibility to creatively solve hard problems. Thanks for listening.